Extension of Wallis formula. We could have already noted that the standard Wallis formula is nothing but In is equal to integral 0 to pi by 2 sine power nx dx is equal to integral 0 to pi by 2 cos power nx dx is equal to n minus 1 by n into n minus 3 by n minus 2 into etc 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 I0 if n is even, I1 if n is odd. And of course we know that I0 is pi by 2 and I1 is 1. Well, this is the standard Wallis formula. What is meant by In? This answer is of course denoted by In. Well done. Now we introduce an extension of this formula like Imn is equal to integral 0 to pi by 2 sine to the power of mx into cos to the power of nx dx. Well, my dear, how to have the proof of this one? In indefinite integration, you could have had the reduction formula In, that is sine power nx. You just catch that and obtain the limits 0 to pi by 2. You will have the answer. You will have the answer. Just like that, the proof of this upcoming formula that which we are going to learn, that is Imn, extension of Wallis formula. We are saying this can also be proved by using integration by parts and then applying 0 to pi by 2. It is a tedious job, of course. It will be a lengthier process, and we are interested in noting down the answer only because it is widely in use at so many problems, at so many occasions. We will be using them. That is why let us observe the answer first of all. See here, the main concentration will be done on m, that is the exponent that is given to sine function. Main attention is on m. Okay, start by the very first expression. The factor is m minus 1 by m plus n. Decrease by 2, m minus 3 by m plus n minus 2. M minus 5 by m plus n minus 4, and so on. Again, two cases will now arise. What are the two cases? You are showing interest on m in the beginning, isn't it? So m is even or m is odd. Two cases will arise. If m is even, we take I0n if m is even, and I1n if m is odd. This is the process of noting down the extension of Wallis formula. That is, as and when you look at two functions, sine power mx and cos power nx as a product, this formula is supposed to be used. Okay, it is not yet completed. It is our duty, it is our responsibility to say what is I0n and what is I1n. Let us try to obtain them. What is I0n? Integral 0 to pi by 2. Come on. In the place of m, you are supposed to take 0. Come on, take 0. Sin x power 0 is, sin x power 0 is 1. 1 into cos power nx, it becomes cos power nx, and which is already known to be In. And you make use of all the formalities of In which were already dealt with in Wallis formula. So if m is even, the last factor will be I0n. I0n is just nothing but In, the In of good olden days of Wallis formula. What is In? As usual, n minus 1 by n into n minus 2, like that. So consideration for n will be dealt with in this extension. So in the beginning, we take interest on m, and in the meanwhile process, n will again be discussed with. This is about I0n. Well, what happens in the case of I1n? It is also to be known, isn't it? What is I1n? Integral 0 to pi by 2 sin x into cos power nx dx. I like to write minus integral 0 to pi by 2 cos power nx into minus sin x dx. Well, my dear, in the beginning, in the earlier classes of indefinite integration, we could have learned a formula. What is that formula? Integral of f of x whole to the power of n dx, n into f dash x dx is equal to f of x whole to the power of n plus 1 by n plus 1. Am I correct? Here, what do you observe in the place of f of x? Cos x. For f dash x minus sin x, absolutely in that similar fashion, so that we have the answer for this will be minus cos x power n plus 1 by n plus 1 between the limits 0 to 1. Well done. Between the limits 0 to pi by 2. Good. What happens to that? It is our duty to simplify. Well, my dear, I would like to remove this because I can save some space here to simplify that. It is minus. Substitute pi by 2 in the place of x. We have cos pi by 2 power n plus 1 by n plus 1 minus cos 0 power n plus 1 by n plus 1. Come on, you know that cos pi by 2 is 0, 0 per anything is 0, 0 by n plus 1 is again 0, this is 0, and cos 0 is 1, 1 per n plus 1 is again 1, 1 by n plus 1, minus of minus 1 by n plus 1 is 1 by n plus 1. So that is the matter about 1 by I1n as 1 by n plus 1. Okay, this is the actual picture of the extension of Wallis formula, that is Imn is equal to. Well, by summarizing all these things, let us have the straight and simple picture of this so-called extension. How can it look? Let us have a look over that. Imn is equal to integral 0 to pi by 2 sin power mx into cos power nx dx is equal to m minus 1 by m plus n into m minus 3 by m plus n minus 2 into m minus 5 by m plus n minus 4 into etc 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 I0n if m is even, and I0n is equal to In is equal to integral 0 to pi by 2 cos power nx dx. This is equal to m minus 1 by m plus n into m minus 3 by m plus n minus 2 into m minus 5 by m plus n minus 4 into etc etc I1n if m is odd. Here I1n is equal to 1 by n plus 1. This is, of course, the brief sketch of this extension of Wallis formula. a beautiful formula. Wherever both sine function and cos function are there involved in a product with different exponents, then evaluating the definite integral of that product between the limits 0 and pi by 2 is explained by using this formula. And it will be very clear, and we will be habituated with that, provided you solve some general numerical problems using this one. We shall now do that. Next one, integral 0 to pi by 2 sine power 4x into cos power 6x dx. As this is the very first example, I have considered both m and n are even. Okay, how many cases will arise? M and n both are even, both are odd, m is even, n is odd, m is odd, n is even. 4 different cases will occur. We shall illustrate the formula, or we shall practice that formula in all these 4 cases. In the first case, we are having both m and n are even. Let us see what is going to happen. Come on, this is dx. I think you could have recollected the formula. It's not possible to write it that such type of a lengthier formula beside that. What is the very first factor? M minus 1, that is 3. M plus n, that is 10. Subtract, decrease to 1 by 8. Any more steps? No more steps. Stop there. Okay, we have stopped. What is this m? Even or odd? Even. So what should you have? I0 n, that is I06. This is equal to 3 by 80 into, what is I06? I6. Okay, this is 3 by 80 into, what is I6? Let us now approach the very first standard Wallis formula to have integral 0 to pi by 2 sine power n x or cos power n x dx denoted by in. Come on, what is the first step? N minus 1 by n, 5 minus 3, 6 minus 4, 3 minus 1, 4 minus 2. Stop. Why should you stop there? Because you need not, it cannot decrease further. Okay. What is n? 6. Even. If n is even, you please recollect the formalities of that Wallis formula. If n is even, at last we will be having I0. What is I0? Pi by 2. What is I0? Pi by 2 into pi by 2. Well, 3 goes 2 times, 5 goes 16 times. Altogether, just 3 pi is available in the numerator, and in the denominator it is 2 square into 2 square, 2 power 4, 2 power 5 into 2 power 4, 2 power 9, that is 512. 3 pi by 512 becomes the answer for that. Like that, like this, we have made use of the formula in the case when both m and n are even. Now, let us see the case when both m and n are odd. I think you could have noticed and you followed this next one. Integral 0 to pi by 2 sine power 9x into cos power 5x dx. You observe this problem. What is the speciality of this problem? Here both m and n are odd. The exponent that has been given to sine function and the exponent that has been given to cosine function, both are odd. Okay, what happens to this case? Come on, what is the starting step? M minus 1 by m plus n is 14. Come on, decrease by 2, 6, 4, 2, stop. 12, 10, 8, stop. Okay. Why did you stop here? Because if you still proceed, 0 becomes in the numerator. No, it's not the case. Okay, it is m is odd here. So what should you have? I1n, since 9 is odd. Okay, this is equal to, there might be so many cancellations it seems. 4 goes 3 times, 3 goes 2 times, 7 goes 2 goes 5 times, 8 and 8 will go away, leaving you just 2 in the numerator. This 2 goes 7 times again. So that 1 by 7 5, so 35 into what is I15? I1n is 1 by n plus 1. You might have noticed we have discussed. We have proved it actually. We have calculated it, isn't it? It is 1 by n plus 1. Hence it is 1 by 1 plus 5. 1 plus 5 is 6. 635 are. 630 so 180, 6 5 so 30, 210. Hence the answer is 1 by 210. Is the answer. Is the answer. So this is an example in which both m and n are odd. Now let us observe the third case, that is m is odd but n is even. What happens? Integral 0 to pi by 2 sine power into cos power 6x dx. What is the case with this problem? M, the exponent on sine function, is odd and n is even. Okay, let us start. Of course, the first step, there is no difference in the first step. What is the very first step? M minus 1, that is 6 by m plus n, 13. Come on, go on, decreasing 2, 2, 2, like that. 4, 2, 11, 9. Stop there. Okay, we have stopped. As m is odd, we should have 1 6, I16. Well, any more cancellations here? 2 3s, 3 3s. No more cancellations. So it is 2 4s are 8, 8 2s are 16 by 13 into 11 into 3 into what is 1? I16, 1 by 1 plus 6. Why? Why should it be written like that? I1n is nothing but 1 by n plus 1, isn't it? Hence, this is therefore 16 by 13 into 11 into 7 into 3. That becomes the answer. And we could have observed almost all 3 cases. There has been another case. What is that case? M is even and n is odd. What happens to that? You please observe the case. M, that is the exponent given to the sine function, is even. N, that is the exponent given to the cos function, is 7, that is odd. Let us observe the answer, the style of simplifying it. Come on. Starting step is m minus 1 by m plus n, that is 15 into 5, 3, 1. In the numerator, 13, 11, 9 in the denominator. Okay, stop there. Now it is, as m is even, you should have I07. I0n, n is of course 7. Any more cancellations? 5 3s so 15, it can be cancelled. Any more? No more. Okay, this 7 by 13 into 11 into 9 into what is I07? I07 is nothing but I7. What is I7? The standard format of Wallis formula. Come on, is it 7 by 13 into 11 into 9 into, come on, n is 7. So what is the starting step there in Wallis formula? N minus 1 by n. N minus 1 is 6 by 7, 4, 2, 5, 3 into what is n? Is it even or odd? Odd. If it is odd, we have I1. What is I1? 1, of course. Now let us observe, any more cancellations possible? 7 and 7 go away. Okay, 3 goes 2 times. Any more? No more, no more. 2 4s are 8, 8 2s are 16. 16 is in the numerator, and in the denominator 13 into 11 into 9 into 5. That's all. What about I1? I1 is nothing but 1, so you can ignore that. You can ignore that. That is the answer. Well done. We have discussed with almost all the 4 cases of the extended formula of Wallis formula, that is integral 0 to pi by 2 sine power mx into cos power nx dx. Yes, let us observe another application of this extension, different forms of this this extension. We shall now observe. Observe the question. Integral 0 to pi sine power 8x into cos power 6x. This is not in the standard form. The limits are not given as 0 to pi by 2. It has been given 0 to pi only, 0 to pi. So we have to recollect the formula. What is that formula? 0 to 2a f of x dx is equal to 2 into integral 0 to a f of x dx if f of 2a minus x is equal to f of x is equal to 0 if f of 2a minus x is equal to minus f of x. Accordingly, we have one more formula also. Integral minus a to a f of x dx is equal to 2 into integral 0 to a f of x if f is even is equal to 0 if f is odd. These are the most important formulas which we generally make use of. Okay, let us do that. In the place of 2a, we have pi. Sine of pi minus x, sine x, power 8, no change. Cos of pi minus x, minus cos x. But you see, whole power 6 is there. So therefore, no change at all. So f of 2a minus x is equal to f of x. So what type of step you have to use? The first step. The first case, answer is 2 into integral 0 to pi by 2 sine power 8x into cos power 6x. Well done. This is in the standard form. You can apply the formula. What is that? M minus 1, 7 by 14 into 5 by 12 into 3 by 10 into 1 by 8 into M is even. So I06. Okay, 7 goes 2 times, 5 goes 2 times, 3 goes 4 times. Any more cancellations? No more cancellations. 2 and 2 will go away. So that this is 1 by 4 2s are 8, 8 8s are 64 into I06. Again, we have to extend this to the standard main Wallis formula In. In the place of n we have 6. Starting step is n minus 1 by n. 3, 1, 4, 2 into n is even. So pi by 2. Come on, think of any more cancellations? No more cancellations. 3 goes 2 times. Anything else? Nothing else. So 5 pi by 1, 2, 4, 5, 6, 2 power 11. That is 2048. 2 4s are 8, 8 2s are 16, 16 2s are 32. 32 is 2 power 5. 2 power 5 into 2 power 6 is 2 power 11. 2 power 11 is 2048. 5 pi by 2048 is the answer. You see, here we have made use of the first formula. Well done. Next one. Integral 0 to 2 pi sine power 8x into cos power 5x dx. What do you have? Again, making use of the same formula. Sine of 2 pi minus x is minus sine x. even then whole power 8 is there, no harm to that, no change will be there. Cos of 2 pi minus x is cos x power 5, no change. Hence we can pull 1 2 out, 0 to pi sin power 8x into cos power 5x dx. Now you observe, in the place of 2a we have now pi. Sin of pi minus x is sin x, no change. Cos of pi minus x is minus cos x power 5, so minus cos power 5x, so the function changes. What type of the case that you have to apply? The second case in this box, hence the answer is simply 0. Answer is simply 0. Okay. Yeah, now I interchange the numbers. What happens? Now you tell me, in this case I have just interchanged the exponents, sin power 5x into cos power 8x. What is the position now? Of course this step is not necessary. Come on, tell me. Sine of 2 pi minus x. What is sine of 2 pi minus x? 2 pi minus, it is in the fourth quadrant, so it is minus sine x. Minus sine x power 5 is minus sine power 5x, but this is positive. Negative number into positive number, negative. So the function changes its sign. The function changes its sign. F of 2m minus 6 has become minus f of x now. Hence the answer is mercilessly 0. Mercilessly 0. Why? Because it is f of 2m minus x is nothing but minus f of x. Now I change it, 0 to 4 pi sin power 7x into cos power 5x. You observe this case. What happens? 4 pi minus x, 4 pi minus fourth quadrant. In fourth quadrant it is negative. Negative power 7 minus sin x whole power 7 minus sin power 7x. Wait. Here. Cos of 4 pi minus x is positive. Positive power 5. So it is also positive. Negative number into positive number, negative number. It changes its sign. Hence the answer is 0. Well, I change the limits like this. Now tell me, what happens to this case? What happens to this case? It is sin pi minus x is sin pi minus x is sin x power 7 positive, but cos pi minus x, it is again 0. Again 0. Like this, you may have to test the given function in the form of the integrand, making use of those formulae. Of course, we have not yet discussed with this. We shall now take one more example in which this formula can be used. Well, integral minus pi to pi sin power 4x into cos power 5x dx. What's your opinion? As it is in the form minus a to a, what is the test that you have to test? The integrand, whether it is even or odd, that you may have to test. Come on, sin power 4x is an even function, cos power 5x is an even function, totally it is an even function. Hence, you can write this as 2 into integral 0 to a sin power 4x into cos power 5x dx. So we have made use of this. Now make use of this. Come on, 2a minus x, cos of pi minus x is minus cos x, power 5 is negative. This is positive, this is negative. Product is negative. So the function changes its sign. Hence the answer is 0. Hence the answer is 0. Like that, we can make use of that formula. Next one. One more. Integral of root of a square minus x square between the limits 0 to a. What happens? What happens? Dx. It is one of the standard results. a square pi by 4, something like that it will be coming. Let us see. How can it be? As its proof is very simple, we observe it. Come on, this is what is the integral without the limits? X by 2 into root of a square minus x square plus a square by 2 into sine inverse x by a between the limits 0 to a. 0 to a. Come on, you put j first of all. A square minus a square is 0. A by a is 1. Sine inverse 1 is pi by 2. A square by 2 into pi by 2. This is all the value that has been obtained by taking a in the place of x. Now you take 0 in the place of x. 0 by 2 is 0. 0 into anything is 0. Sine inverse 0 by a is 0. Sine inverse 0 is 0. Hence it is 0. Ultimately the answer is a square pi by 4. A square pi by 4. And this standard problem will now become a standard result or a standard formula. As in when you look at integral 0 to a root of a square minus x square dx, it is just nothing but a square pi by 4. A square pi by 4. Look at this. Come on, tell me. Integral 0 to root 2 square root of 2 minus x square dx. Is this problem in this standard form or not? In the place of a square we have 2, in the place of a we have root 2, hence the answer is a square pi by 4. So the answer is pi by 2. Root of 9 minus x square dx. What are you having in the place of a square? 9. And in the place of a we have 3. So the answer is a square pi by 4. That is 9 pi by 4, isn't it? 9 pi by 4. Well, integral 0 to 1 root of 1 minus x square dx is again just to pi by 4. Why? Because answer 1 is, in the place of a we have 1. This is the standard answer. Well, next. Integral of x power m into 1 minus x whole to the power of n dx between the limits 0 to 1. One more standard question. Well, you see, it can easily be simplified by taking x is equal to sine square theta or x is equal to cos square theta. It can then be converted in terms of IMN formula, the previous one. Of course, by getting it simplified by using the extension of Wallis formula, namely IMN formula, at last you will have the beautiful result as m factorial into n factorial by m plus n plus 1 factorial. One of the famous answers. Well, my dear friends, I could have explained the way of getting it. That is by taking x equal to sine square theta or something like that. Of course, it is not a very simple one. It takes some 5 to 6 or 7 steps, and it is a matter of time now. So you please believe the answer to be like this. Okay, let us observe. You see, one formula will be owned by us when and only when if you solve some problems related to that. Yes, it has to, it may have to be acquainted with our mind. Look here. Integral 0 to 1 x square into 1 minus x whole cube dx. What is that? 2 factorial into 3 factorial by 2 plus 3 plus 1, that is 6 factorial. You simplify according to that. Integral 0 to 1 x to the power of 5 into 1 minus x whole to the power of 4 dx. Come on. What is the answer? It is 5 factorial into 4 factorial by 5 plus 4 plus 1 is nothing but 10 factorial. Like that we have it. Well, let us verify the formula with simple example. Look here. Integral 0 to 1 x into 1 minus x dx. What is it? According to the formula, the answer must be m is 1, n is 1. So 1 factorial into 1 factorial by 1 plus 1 plus 1 factorial. Hence the answer must be 1 by 6. Shall we verify? Just for the sake of fun, let us verify. Come on, x into 1 minus x is nothing but x minus x square dx. For x, the answer is x square by 2. For x square, it is x cube by 3. Between the limits 0 and 1. Answer is, you substitute 1. 1 by 2 minus 1 by 3 minus 0 is just nothing but 1 by 6. That the formula is absolutely correct. Hence the formula is absolutely correct. It has been verified with this simple example. Hence the formula is m factorial into n factorial by m plus n plus 1 factorial, one of the standard results. Well, 0 to pi by 2 f of sin x by f of sin x plus f of cos x dx is equal to integral 0 to pi by 2 f of cos x by f of cos x plus f of sin x is equal to pi by 4. Just like this, integral 0 to pi by 2 f of tan x by f of tan x plus f of cot x is equal to integral 0 to pi by 2 f of cot x by f of tan x plus f of cot x is again pi by 4. Similarly, integral 0 to pi by 2 f of secant x by f of secant x plus f of cosecant x dx is equal to integral 0 to pi by 2 f of cosecant x by f of secant x plus f of cosecant x dx is again pi by 4. Like this, we can have standard results as many as we can. We shall now look at some more standard results in these definite integrals. Integral 0 to pi by 2 a sin x plus b cos x by sin x plus cos x dx. What happens if you apply the formula 0 to a f of x dx is equal to f of a minus x dx? Then it is a cos x plus b sin x by cos x plus sin x. That will be I. You add that I plus I is equal to a plus b sin x plus a plus b cos x by sin x plus cos x again, and sin x plus cos x can be cancelled, leaving you a plus b into pi by 4, isn't it? A plus b into pi by 4. Okay, let us observe its proof. It's very simple. As it is simple, only I am tackling with that. Come on, I is equal to integral 0 to pi by 2 a sin x plus b cos x by sin x plus cos x dx. Again, integral 0 to pi by 2 a into, in the place of x, let me write pi by 2 minus x so that it becomes a cos x plus b sin x by sin x, sin pi by 2 minus x, cos pi by 2 minus x, sin x dx. This is also I. Now add these two. 2I is equal to integral 0 to pi by 2. Come on, friend. Sin x plus cos x, the same denominator. A sin x, a cos x, a into sin x plus cos x. B cos x, b sin x, b into sin x plus cos x. a into sin x plus cos x plus b into sin x plus cos x. If you can divide both numerator and denominator with sin x plus cos x, what is going to happen? Just a plus b. A plus b. Hence, this is a plus b into x between the limits 0 to pi by 2. Why? Because a plus b into integral 1, isn't it? So, it's nothing but a plus b into pi by 2. Well, my dear, is it I or 2i? It is 2i. So, it is I is a plus b into pi by 4. The formula is correct. Therefore, integral 0 to pi by 2, 5 sin x plus 6 cos x by sin x plus cos x is, come on, a plus b 11 pi by 4. 11 pi by 4. Integral 0 to pi by 2, 3 sin x minus 4 cos x by sin x plus cos x. What do you have? In the place of a and b, we have 3 and minus 4, hence it is minus pi by 4. Like that, you can make use of this simple formula. Integral a sin x plus b cos x by sin x plus cos x is a plus b into pi by 4. My dear friend, not only like this, you can have two more such results. What are they? Integral 0 to pi by 2, a tan x plus b cot x by tan x plus cot x is equal to a plus b into pi by 4. Integral 0 to pi by 2, a secant x plus b cosecant x by secant x plus cosecant x is again a plus b into pi by 4. Beautiful results that can be used anywhere else as and when they are required. Please have a look over that. Please follow them. Integral 0 to pi by 2 dx by a square sin square x plus b square cos square x dx is equal to. Well, look at this problem. Actually speaking, it is a famous problem. You see, it can be solved by dividing both numerator and denominator with cos square x, and by taking a by b tan x as t, you can simplify, of course, in the place of secant square x dx, we can have dt like that. If you simplify that, the answer will be pi by 2ab, one of the standard answers. It is pi by 2ab, pi by 2ab. Okay, integral 0 to pi by 2 dx by 3 sin square x plus 12 cos square x is. Answer please. In the place of a square we have 3. In the place of b square we have 12. So the answer is pi by 2ab, pi by 2 root 3 into root 12. Root 3 into root 12 is root 36. Root 36 is nothing but 6. So the answer is pi by 12. This is the answer. This is the answer. This is also a beautiful format. You have a note of that. You observe these questions. They look alike. Of course, logarithmic function is being involved here. And if you take f of x integral 0 to a f of x dx equal to f of a minus x dx and getting it simplified, you will be having the answer. This see, my dear friend, this is a famous answer. Minus pi by 2 log 2, minus pi by 2 log 2, and this is of course 0. Why? Because I is log cot x. You take pi by 2 minus x in the place of x, it is log tan x. What is I plus I? Log tan x plus log cot x is log tan x into cot x, that is log 1. What is log 1? 0. So this is 0. Similarly, this is also 0. So these you are supposed to get it. Remember that integral 0 to pi by 2 log sin x dx is equal to minus pi by 2 log 2, and integral 0 to pi by 2 log cos x dx is also minus pi by 2 log 2, whereas integral 0 to pi by 2 log cot x dx is 0, integral 0 to pi by 2 log tan x dx is also 0. Yes, these are famous answers you see. He may not ask you directly this question. In the questions he generally asks, these may come under. These might be under use. That is why you may have to recollect and remember them. Yes. Another beautiful result. Integral 0 to n integral part of x dx. Whatever you call integral part of x or step x or the greatest integer function like that. If n is a natural number, this or n is an integer even. Integral 0 to n integral part of x, integral part of x dx. How much? It's very simple. Yes. Its proof is also simple. Let us instead of the answer, let us have the proof. Of course, the answer is n minus 1 by 2 is the answer. Now, I like to derive this. This is equal to integral 0 to 1 integral part of x dx plus integral 1 to 2 integral part of x dx plus integral 2 to 3 integral part of x dx, and so on, etc., etc. At last, integral n minus 1 to n integral part of x dx. You can observe 0 to 1, 1 to 2, 2 to 3, 3 to 4, etc., etc. n minus 1 by n minus 1 to n. It leads to the LH, that is integral 0 to n integral part of x. Come on friend, between 0 and 1, what is the integral part of x? 0. So integral 0 to 1, 0 dx. Integral 1 to 2. Between 1 and 2, what is integral part of x? 1. 1 dx plus integral 2 to 3. Between 2 and 3, what is integral part of x? 2. 2 dx. And so on, integral n minus 1 to n minus 1 dx. It is of course 0. You leave it here. 1, x between the limits 1 and 2 is 1, 0 plus 1 plus between 2 to 3 is, it is 2x dx, it is 2 plus 3 plus 4 plus etc. and minus 1. What is that? 1 plus 2 plus 3 plus etc. and minus 1 is just nothing but n minus 1 into n by 2 or n into n minus 1 by 2. So this is one of the famous answers. It is so famous that you may have to recollect and remember and use as and when it is required. It is beautiful. Yes. So, integral 0 to n integral part of x dx is n into n minus 1 by 2. Very good. Integral 0 to 3 integral part of x dx. Come on, can you tell me the answer? 3 into 3 minus 1 by 2. The answer is 3. Integral 0 to 5 integral part of x dx. Come on friend, what is the answer? 5 into 4 by 2. Answer is 10. These are all the applications. One more integral 3 to, no, 0 to 10 integral part of x dx. What is the answer for that? 10 into 10 minus 1 is 9 by 2, 90 by 2 is 45. Like that, we'll be making use of that formula, which is a beautiful and famous formula. The next one. One more standard result we like to derive. Integral 0 to a x into a minus x whole to the power of n dx. How to get it? Call this I. Now, I can replace x by a minus x, isn't it? So, it is 0 to a minus x into a minus of a minus x is a minus of a minus x is just x dx. So this is integral 0 to a into x power n minus x to the power of n plus 1 dx. Okay, so this is a into x power n plus 1 by n plus 1 between the limits 0 to a minus x power n plus 2 by n plus 2 between the limits 0 to a. Am I correct? For this it is a into x power n plus 1 by n plus 1, and for this it is x power n plus 2 by n plus 2. Okay friend, hence this is, you put a in the beginning, a into a power n plus 1, a power n plus 2 by n plus 1. Minus, if you put x is equal to 0, this becomes 0, no problem. What about the next fact, that is a power n plus 2 by n plus 2? You pull a power n plus 2 out, a power n plus 2 into 1 by n plus 1 minus 1 by n plus 2. Is nothing but a power n plus 2 by n plus 1 into n plus 2. Am I correct? N plus 2 minus of n plus 1 is just nothing but 1 by n plus 1 into n plus 2. So it is a famous answer, beautiful answer. Hence we write, we frame, we construct this also as a formula. Integral 0 to a x into a minus x whole to the power of n dx is therefore equal to a power n plus 2 by n plus 1 into n plus 2. So the answer is integral 0 to a x into a minus x whole to the power of n dx is a power n plus 2 by n plus 1 into n plus 2. Yes, of course. Let us practice this result also. What is the formula? Integral 0 to a x into a minus x whole to the power of n dx is therefore equal to a power n plus 2 by n plus 1 into n plus 2. Okay, integral 0 to 2 x into 2 minus x whole to the power of 5. Come on, in the place of a we have 2 power, in the place of n we have 5 plus 2 by 5 plus 1 into 5 plus 2. So the answer is 2 power 7 by 6 into 7, that is 42. That is 42. So it is 2 power 6 by 21, 64 by 21. That gives you the answer. Like this, we make use of that. Next one. Integral 0 to infinity dx by x plus square root of x square minus 1 whole to the power of n. This can be achieved in so many ways. You can take x as secant theta, or x plus x square root of x square minus 1 as t, like that, and the ultimate answer is n by n square minus 1. Ultimate answer is n by n square minus 1. So you please remember it. Integral 0 to infinity dx by x plus square root of x square minus 1 whole to the power of 5. Come on, the answer is 5 by 25 minus 1 is 24. Integral 0 to infinity x plus square root of x square minus 1 whole to the power of minus 8. Come on, what is the answer? What are you having in the place of n? We are having 8 in the place of n, hence the answer is 8 by 8 square, 64 minus 1, that is 63. 8 by 63. Like that we simplify.